Alright, so here we go for this last section of problems. We've got the integral of a sum, and it's just the sum of the integrals. Okay, so that's one thing that is important to understand. So we have negative 2 to 5 of f of x, and I'm going to use shorthand here. No, I won't, because it's your first day. Plus negative 2 to 5 of g of x dx minus the integral from negative 2 to 5 of h of x dx. Okay, and so what's the integral from negative 2 to 5 of f of x? That's 18. And then the integral from negative 2 to 5 of g of x, that's 5. Oops. And then h of x, that should be minus h of x, and h of x, negative 2 to 5, is negative 11. So 18 plus 5 is 23, plus 11, that's 34. Okay, so 34 is the answer to number 23. You go ahead and do number 22. And let me use a different color. In fact, let me use, where's my blue? I don't have, oh, there it is. Okay. Alright, so pause the video, do this one. Maybe you've already paused it, and maybe you've already done it. Negative 2 to 5 of f of x, that's 18. Negative 2 to 5 of g of x is 5, so we have 23. Okay. And what about this one? This one, the tendency, and I'm going to do number 25. Okay, the tendency is to think, oh, the integral from negative 2 to 5 of g of x is 5, and do not put plus 2 equals 7. It is not 5 plus 2. It's 5 plus the integral from negative 2 to 5 of 2 dx. Understand? When you're integrating, you're actually accumulating area. And if you think about what this would look like, if you draw a picture of it, here's negative 2, here's 5, and then there's y equals 2. So when you're integrating a constant, what you're really doing is you're finding all of this area. So it's the constant times the length of the interval, and the length of the interval is 7, times 2 is 14. So 5 plus 14 is 19. Okay, so you go ahead and do number 26 on your own. So negative 2 to 5, pause the video, negative 2 to 5 of f of x is 18, minus the integral from negative 2 to 5 of 6 dx. Okay, the integral from negative 2 to 5 is, the interval is 7. 7 times 6 is 42. 18 minus 42 is negative 24. Okay. Now this next one's a little bit tricky. 27. The integral from 0 to 7 of h of x minus 2. Well, keep in mind that let's draw a little picture of what's going on. This is a great problem. I love this problem. Okay. If we put h of x somewhere, we know that the integral is negative 11. So what I like to do is from negative 2 to 5, I'm going to draw a picture of what I just think is the, let's do it like this. So negative 2 to 5, the integral from negative 2 to 5, my apologies, is negative 11. So the area here is 11. Okay, so we don't know what h of x looks like, and this is just to find h of x. But if you remember back in pre-calc honors, h of x minus 2 is what we need to graph. And h of x minus 2 means we're going to take the graph of h of x and we're going to shift it to the right 2 units. So if we take this point here and we move it 2 units to the right, we get that one. 5 move 2 points to the right, we get that one. And then we get the same graph, which has an area of 11, which means that the integral from 0 to 7 now of h of x minus 2 is the same as the integral from negative 2 to 5, which would be negative 11. How about that? Okay. Well, let's see here. For number 29, we're almost done. Number 29, we've got the integral from 5 to 8. Okay, so this is how I like to build these problems. We know that the integral from negative 2 to 5 is 18. Okay, from negative 2 to 5 is 18, so I'm going to write negative 2 to 5 there. and I'm just going to do this. I'm just going to say that's my f of x, okay, 18. It also gives us that negative 2 to 8 is 0, okay. Oh, sorry, you couldn't see that. So this is our f of x. This is my version of f of x. We're not given any more information other than the net area between the curve and the x-axis between negative 2 and 5 is 18. Okay? And then from 5 to 8, we know that the integral from negative 2 to 8, it's given to us to be 0. So from 5 to 8, has to counterbalance or counteract whatever, or negate what we accumulated from negative 2 to 5. So if we accumulated 18 units from negative 2 to 5, we have to lose 18 units from 5 to 8. So the area between negative 2 and 5 is 18. The area between 5 and 8 is also 18, but underneath the x-axis. And now we're being asked to find the integral from 5 to 8. Well, the integral from 5 to 8 then would be negative 18. That's the way I like to do those problems. It makes it much easier for me if I can see a picture like that. You might see maybe a more complicated example in the book of how to do that problem, but just drawing a quick picture makes it really, really easy to visualize. So number 30, you get the task of doing number 30 on your own. From 1 to 8, okay, 1 to 8 of f of x minus 3. So I can use this. You should have paused the video already. Please do that if you haven't done that yet. Try to figure it out. I already have my f of x. I know that f of x minus 3, that's what we have here, okay, if we move this point over 1, 2, 3. So we're shifting the graph of f of x to the right 3 units. So we go 1, 2, 3, and we put the point there. Everything gets shifted over 3 units. 1, 6, 7, 8, and 8 goes to 11. Okay, so we go from here all the way to here, and then from there to there. So we have 18 there, I have 18 down here, and we're asked to find the integral from 1 to 8 of f of x minus 3. So let me do it in a different color. 1 to 8 of f of x minus 3. Well, we know that that's going to be 18, plus the integral from 1 to 8 of 3 dx. Okay. Do not add 18 and 3. That's the tendency. Your brain wants to do that. It's fooling you, though that's not the right answer. Remember, when you're integrating, you're accumulating area. It's not linear. Okay, so the integral of 3 is not 3. It's 3 times the length of the interval. Okay, so f of x minus 3, we know, again, that's 18 plus, and if you want to build that function, 1, 2, 3, from 1 to 8, we can see that it's 3 units high, and 1 to 8 is 7 units long. So this interval here, from 1 to 8, 7 units long, and the area of the rectangle is 3 units high, so 7 times 3 is 21. So 18 and 21 make 39. And I may or may not have other problems for you to try. I'm going to try to find some multiple choice ones so that you can do some problems, and then you can... I'll have something else for you to do, put it that way, because I need to get some feedback and see what you know and what you don't know. I might even ask you for some verbal feedback anyway. So I hope that helps, and when you come back the next day, we're going to be doing some of these problems here, okay, from the definite integral as area homework. So make sure you bring this to class with you, and we'll work on some problems in that section. We'll see you then.